is the study of geography, and these are the branches of geography: physical geography, human geography, and practical geography. These are among the few topics that we look at when we study geography. We look at industrialization, we look at forestry, we look at tea plantations, maize plantations, brick making industry, among many others. Welcome to Geography Form 1 lesson.
Your teacher is Sarah, and you are welcome to our Form 1 work. And we are going to talk about the structure of the earth. And today we are looking at the external structure of the earth. The last time we talked about the internal structure of the earth. We said there are two structures. The earth has got two structures. There's the internal structure and there's also the external structure. And if we can remind ourselves briefly, we said the internal structure, that is now what we can call in our layman's language, the ground, is what is the internal structure. And the internal structure has got three main layers. We have the crust on the outside, on which we work and we build houses, we plant crops and vegetation. And there is the mantle right in the middle, and then right in the inside there is the core, which we also call the Stratosphere. And today we are going to embark on the external structure. And the external structure of the earth is made up of two parts. We have the hydrosphere and we have the atmosphere. Those are the two parts that make the external structure of the earth. Now, the external structure of the earth, as we have said, has got two sections. We have the hydrosphere and we have the atmosphere. Let us start off with what we call the hydrosphere. The hydrosphere is the part that is occupied by water masses. The water bodies is what we call the hydrosphere. It is 73%, you see, over 70% of the earth's surface is covered by water, and that is the hydrosphere. Now, the internal structure of the earth and the lower layer of the atmosphere, those three are the ones that can support life. That's where life is possible. I have said the lower part of the atmosphere, which is the external structure of the earth. We have the hydrosphere, which is the part that is covered by water, and we also have the thin part of the crust, the shell, is what can support life. Yes, when you dig the ground, you find animals there, burrowing animals. You have earthworms, you have rats, you see, all those ones, they are able to survive in water. Even plants, we talk about the lower part of the atmosphere, where we are. Yes, we are able to walk around and we are enjoying life. It's for free. The hydrosphere, which is the water. Yes, if you look into the ocean life, you see so many animals there. See the whales, the sharks, all the fish, all the types of fish and amphibians, they all live in water. Life is possible in the lower part of the atmosphere, and it's also possible in the upper part of the crust. Now, when we look at the external structure of the earth, that is the atmosphere now, what is the atmosphere? Maybe we start by defining it. So it is a thin layer that is surrounding the earth's surface. It is a thin layer that is made up of air, humidity or water vapor, and dust and smoke particles. And this layer, I'm referring to it as being thin because space has got no end. It's extending past where we can even imagine. But the Earth's atmosphere is only about 140 kilometers. I'm trying to say that it is sensible for us to refer to the atmosphere as a very thin layer of gases and water particles or molecules, that is surrounding the Earth's surface. Now, this atmosphere is held to the Earth by the force of gravity. It does not slip off. As much as the Earth is moving, we said the Earth makes two types of movement. There is the rotation, there is the revolution. Revolution is forward movement. You see, the Earth moves forward at a speed of about 23 miles per second. 23 miles per second, my dear, is a very fast speed. But the Earth does not let go the air. It moves with the air together because the air is held to the Earth by the force of gravity. Very good. Now, this air, this atmosphere, as we see it here, as we have it, is arranged in layers, just like the way we saw the internal structure of the Earth, which is arranged in layers. This one is also arranged in layers. We have the lowest layer, then we have another layer, which is the second layer. We also have the third layer and the fourth layer. In some books, you can even find them saying there is the fifth layer. So we are going to look at these layers. We have at the lowest or at the bottom, next to the Earth's surface, is the troposphere. These layers are called spheres. So we have the troposphere as the lowest layer or as the first layer from the bottom. Then we have the second layer, which is called the stratosphere. Then we have the mesosphere as the third layer. And then we have the thermosphere as the fourth layer. Those books that tell us that there is the fifth layer, it is called the exosphere. The troposphere as the lowest layer. And we look at some of the characteristics of the troposphere. Number one, we have said it is the lowest layer. This layer contains all the weather phenomena. It contains all the weather elements. Name them. We have sunshine. We have temperature. We have cloud cover. We have humidity. We have winds, air pressure. All of them, they are available here. And therefore, this layer is very unstable. There's a lot of energy. We have water moving up and forming clouds and rainfall forming, There is rain formation. There's a lot of instability in this layer. And we are going to look at the behavior of these weather elements. Maybe we can start with the temperature. At this lower level of the Earth's atmosphere, the troposphere, this layer, the temperatures here, they reduce as you increase in height. There is temperature decrease with increase in altitude, height above the sea level. The temperatures reduce at some rate of about 2.1 degrees Celsius at a rise of about 300 meters. So if you calculate it from sea level, and you know the temperatures at the sea level, you will be able to give a reason why Mount Kilimanjaro, Mount Kenya, they are covered by solid water at the top. We have said character number one is that the temperatures reduce as you increase in altitude. Number two, we have atmospheric pressure. Atmospheric pressure is the weight of the air. And the weight of the air decreases as you increase in altitude as well. The air molecules are more down here where we are. As we rise up, they become much less, and therefore their weight is also as well less. What about the winds? The winds here, they are not destructive. They are not disturbing because the winds, the speed of the wind has been reduced seriously. The speed of the wind has been reduced because of the presence of mountains, the presence of vegetation, buildings, wind is obstructed. Wind increases in speed where there are no objects. If it moves a long distance without getting in contact with an object, then the speed will obviously increase. So the velocity of the wind is almost at calm. It's very low because of the presence of the objects like buildings, as we have said, in mountains or hills. Now, clouds are also found in this level, and we also have humidity, water vapor is also found abundantly in this level. So that is the characteristic of the troposphere. The troposphere here at the equator, it's about 15 kilometers, and as you move nearer the poles, it moves down to about 8 kilometers vertically into the air, and that is the troposphere. The troposphere is neighbored by the stratosphere, which is the second layer, but it is separated from the stratosphere by a discontinuity layer that we call the tropopause. The tropopause is a discontinuity layer which has got everything remaining constant, temperature, everything. There is no change, especially of temperature. The temperature remains constant, and therefore it is called a discontinuity layer, after which we get into the stratosphere. The stratosphere is our second layer in the atmosphere. This layer that we have, which is the stratosphere, runs from about 10 kilometers above the ground. Then it runs up to about 40 kilometers, 45, around there. Now, this layer is comprised of excess oxygen molecules, what we call the ozone gases. We call it, therefore, the Ozonosphere. It is called the Ozonosphere because of the presence of the ozone gases. These are excess oxygen molecules. Now, the excess oxygen molecules have a purpose there. This second layer is a preventive layer. It prevents us from getting attacked by falling foreign objects. They are foreign objects which are falling from the outer space. And as they are moving in space, if they come nearer the Earth's surface, then the objects will be pulled to the Earth by the force of gravity of the Earth. So as they come, they might do a lot of damage. If they fall on people, they fall on property, they will cause a lot of destructive. And in this case, therefore, there is these excess oxygen molecules. We said earlier that there is a relationship between subjects. And one relationship here, there's some important information that we get from chemistry, that oxygen supports combustion. It supports burning. So those objects which are moving from the outer space, there is also the issue of friction, and therefore most of them, they are already red hot. When they come and they get submerged in the excess oxygen molecules, what happens? They get burnt up, they become dust, and they get blown away. And we are safe here. We are very safe. Those objects will never come. There are millions of them which come dropping towards us, but they are captured there, and they are burnt, and they get completely destroyed. We don't even manage to have even the dust reaching down here. And those are the objects that we call the meteors. We had talked about them when we were introducing ourselves to geography. Meteors are objects which are falling from the outer space. And if they may manage to reach here on the Earth's surface, then we call them the meteorites. Let us leave talking about them because they do not even reach here. Beautiful. Now, so this second layer has got excess oxygen molecules, which we call the ozone gases, and that is what we have said. We can also say that the temperature here behaves in a different manner from the way the temperature at the troposphere were behaving. The temperature in the stratosphere increases with increase in height. And this is because of the presence of the oxygen and the burning objects. And so the temperature increases with increase in height. Air, the speed of wind is also increasing with increase in height, in altitude. Why? Because there are no objects which are obstructing the wind. So we are talking about wind. The speed of wind is increasing as you increase in height. The temperatures are increasing with the increase in height. There is excess oxygen molecules there. And then we are also talking about the presence of no clouds. There's very little water, vapor. And we can also talk about air pressure. Air pressure reduces with increase in height. That is the story that we have. As you approach the upper part of the stratosphere, we are talking about another discontinuity layer, which is separating the stratosphere from the third layer. And this discontinuity layer is what we call the stratopause. It is very similar to the troposphere, which was the first discontinuity layer, and that is the temperatures here remain constant. Then now we talk about the third layer above the ground, above the Earth's surface, and that is the Mesosphere. The Mesosphere runs from about 40 or 45 kilometers above the ground to about 80 kilometers above the ground. And this layer is very similar to the first layer, which is the troposphere. In this layer, the temperatures drop in the temperatures drop or decrease with increase in altitude, and atmospheric pressure also decreases with increase in altitude. There is no oxygen molecules here. There is no air. There is no much air. Atmospheric pressure is very low. Then we talk about the upper part of the Mesosphere, which is bordered by the Mesopause, which is a discontinuity layer, above which we have the fourth layer. The thermosphere is also named the Ionosphere. It is called the Ionosphere because it has got excess ion molecules there, and these ions, they help in capturing the ultraviolet rays from the sun, which are actually very harmful if they could reach down here. The temperatures here, they increase with increase in altitude. Atmospheric pressure decreases with increase in altitude. The winds there in the third layer, in the fourth layer, they are very strong because of the presence of no objects. You know, there's the absence of objects. We don't have trees, we don't have mountains. That is the space that is a little far away from us, and that is the thermosphere. Then we talk about the thermopause, which is the upper limit, the discontinuity layer, that is the end point of the thermosphere. Then we have the exosphere, which is running from around 130 kilometers outwards, and it ushers the Earth's atmosphere into the universe, which is the space that is beyond the Earth's surface. It is the space now that is extending. The space beyond the exosphere is extending to reach the atmospheres of other planets. So it is not ours. Ours is actually the four layers. We have the troposphere, we have the stratosphere, we have the mesosphere, and we have the thermosphere. Those are the four layers. And we said the atmosphere is a section of the Earth's external structure, we also have the hydrosphere, which is the part that is occupied by water. Now, the two sections are interrelated. There is some reasonable relationship between them, and they are very important. Water from the hydrosphere is the one that is evaporated by the sun to add humidity into the Earth's atmosphere. You see? So there is a relationship that water is evaporated and it is added into the atmosphere. Now, when the rain is falling from the Earth's atmosphere, it falls to the water bodies and even to the ground. And yes, we are also talking about clouds. They are formed in the Earth's surface, and they condense and they form a lot of rainfall. That is the water vapor condenses, forms clouds, and these clouds, they become heavy. They are pulled down to the Earth's surface by the force of gravity, and we receive rainfall. You see, there's some very great relationship between the hydrosphere and the atmosphere. So they are operating together. We can also say that we have the air is found. We have air in the water, we have air in the atmosphere. This air is the same, so it just mixes around like that. So that is maybe what we have been able to study today, and we are very grateful that you have joined us, and may you have a nice time. Thank you.
We're very grateful that you found time to watch our content. Kindly press the subscribe button down there and leave a like if the content was helpful to you. Join us in the next lesson. Thank you.